Hello and welcome back to Global Math Mentor. This is part 2 of the discriminant lesson. B squared minus 4ac is known as a discriminant, and it helps us find the nature of roots of a quadratic equation. This course covers additional mathematics as well as A-level pure mathematics 1. So this is the subject criteria. Find the discriminant of a quadratic polynomial and determine the number of real roots of a equation. Real roots can be real, equal, or real distinct. And then they are saying knowledge of the term repeated root is included. We also discussed about imaginary roots in each of the cases when the discriminant is greater than 0, equal to 0, and less than 0. So if you haven't watched the first part, make sure you watch that first video to grasp the concept of discriminant, right? So in the first video, I discussed just type 1. If an equation is given, for example, x squared plus 5x minus 6, and I want you to find like what kind of roots this equation have. So you will find the discriminant b squared minus 4ac, and since this is a positive value, you will say it has two distinct roots. We also discussed how the shape of the parabola looks like. In this case, your graph will intersect the x-axis at two distinct points. Now, the type 2 problem, we will flip the script. So it's a reverse operation now. I'll give you an example. What do I mean by that? For example, if you have a quadratic equation, let's say x squared minus kx plus 10 equals to 0. And this time, there is an unknown, and the question says, let's say, the roots of this equation are equal or repeated. What is the value of k? So you get the idea. Previously, the nature wasn't known, and we were trying to find the nature of roots. Now we know the nature of roots, and we need to use discriminant to find that unknown's value. Question structure might turn into an equation or sometimes an inequality. Just in this case, as I said, repeated roots. So you know that b squared minus 4ac will be equal to 0. If they say distinct, you'll put it greater than 0. If they say the roots are not real, then you will put it less than 0. So let's discuss some questions and uh, see how do you tackle these kind of questions, right? Grab on your notebooks and let's start solving some of these type of questions. Problem 1. The equation x squared plus 4x plus k equals to 0 has real and equal roots. So we know that real and equal roots means that discriminant must be equal to 0. So b squared minus 4ac, put it equal to 0. 16 minus 4k equals to 0. So 4k equals to 16 and k should be 4. So that is what I mean by a reverse operation question. Since the nature of roots is given already, it's known, and we're trying to find an unknown, right? If you want to try question 2 on your own, you can pause the video and give it a go, and then come back and check my solution. Question 2. They're saying the equation 2x squared plus px plus 3 equals to 0 has real and distinct roots. So we know that it's time real and distinct roots. Find the range of values for p. So this time the value of the discriminant b squared minus 4ac will be greater than 0. So p squared minus, this is 8 3s are 24 and greater than 0. Oh, this looks like a quadratic inequality, right? So how do you solve it? Even this value over here is not a perfect square. So I'll tell you what you can do in such cases. So make it p squared minus root 24 whole square and greater than 0. I'm trying to solve this quadratic equation using the difference of two square logic. So p minus root 24 and p plus root 24 greater than 0. Sketch a parabola, just like we've learned in solving quadratic inequalities. This will be One of the root is going to be a negative root 24, and the other is going to be a positive root 24. Since it's greater than 0, so the region which is required is this one and this one. If you have problems solving quadratic inequality, you can check my video on that. I'll share the link in the description, right? Okay, so the answers are going to be P greater than root 24, or P should be less than minus root 24. These are the required range of values of P. You can even give this root 24 as, okay, let me just rewrite the solution. P greater than, so since it's 6 times 4, this will be 2 root 6, or the simplest third form can be less than minus 2 root 6. Okay, let me just box this range. Okay, now we do the last part. Again, you're most welcome if you want to solve it on your own. Go ahead, give it a go. Pause the video and come back and check my work later. Okay, problem 3. I'm going to solve it over here. They're saying the equation x squared plus mx and plus n equals to 0 has imaginary roots. Okay, so m is given, m is 4. So I can substitute the value of m. Now this equation looks like this. Since the roots are imaginary, again, I need to solve this quadratic inequality. So b squared minus 4ac will be less than 0. This will be 16 minus 4n less than 0. Oh, good. This time it's not a quadratic inequality, it's just a linear inequality. So I can solve it like 4n greater than 16 and n will be greater than 4. So that is the range of values of n. So you see, students, these structures of questions, since you're using discriminant, if roots are repeated, you will always have an equation. If roots are not real or distinct, you get inequalities, and these inequalities can sometimes be the quadratic inequalities or the linear inequalities. Okay, let's now think about how a line and a curve can meet each other, right? And how does the discriminant help us solve situations like these? So look at this. The syllabus says conditions for a given line to intersect a given curve, be a tangent to the given curve, not intersect a given curve. So I'll show you the sketches, like what do they mean by these. So I've got a parabola and there's like a random line, not the x-axis, but apart from like a random y equals mx plus c line. Okay, I'll make like a slanted line like this. These are the situations like where the line intersects the curve, or line can be tangent to the curve or just touch it or meet at a point. And in some situations, a line might not meet. The same situation can work the other way around. What if the parabola is like upside down? It depends on the value of a. In a quadratic equation, ax squared plus bx plus c equals to 0. This a greater than 0 gives you parabolas like these, and a less than 0 gives you parabolas like these, the one which I'm making right now, the one with the maximum turning point, right? So the same situation can occur in these situations as well. Okay, so now I'll solve some questions for you, and you can relate like how do you tackle these kind of questions. Problem 1. Given that the line y equals mx plus 1 and the parabola y equals to x squared minus 3x plus 2. They're saying find the values of m for which the line intersects the parabola at 2 points. So we know the nature, but unlike the previous set of problems that I solved earlier in this video, there was only one equation. Now we've got a line and a curve. So we need to check like what are the points where the line intersects the parabola. So first of all, I need to equate them. If you have seen the video on solving linear and quadratic system, you know what I'm talking about. But if you haven't, you can take your time and watch that video. Okay, so x squared minus 3x minus mx and plus 2 and a minus 1. So what did I just do? I subtracted mx on both sides and I subtracted 1 on both sides. Let's just standardize it. Okay, watch out for this step that I'm going to do now. You can factor out the negative. You can either write 3 plus m or m plus 3. and then you can put a 1. So by doing so, what happens? You can put a 0 over here as well. So I've got A equals to 1, B equals to a negative M plus 3, and C equals to 1. Let's apply discriminant. So they are saying that intersects the parabola at 2 points. So I know that the value of the discriminant this time is going to be greater than 0. B squared minus 4a and c, and put it greater than 0. This will be the negative square becomes positive, expanded m squared plus 6m plus 9. Know your expansions. Okay. So this will be m squared plus 6m and plus a 5. Now this is a quadratic inequality. How do you solve it? First you factorize it, 5m and 5 greater than 0. Factor out the m and plus 1 and m plus 5. So what is my factorization? M plus 1 and m plus 5 greater than 0. So I'm going to zoom it out a bit, and now I'll sketch a parabola like this. It's just a rough sketch, and decide what is the required region. This will be a negative 5, this will be a negative 1. So since it's a greater region, I need to check those regions where this quadratic function is greater than 0, or you can say above 0. You can either give your solutions this way as well, like this or this. So it will be x should either, oh, sorry, that's m. M should either be less than minus 5, or m should be a greater than minus 1. That's it. So, I mean, the discriminant problem can't get difficult than this. This is like the tier 3 problem, you can say, on discriminant, right? So some of you are here just for revision purpose, I guess, but some of you are really, really new to this. So for those who actually know how to solve this question, you can pause the video and try it on your own, right? And then you can check my work later. So determine the values of c for which the line y equals to 2x plus c does not intersect the parabola y equals to x squared minus 4x plus 7. So this is where sometimes I believe that students get a bit confused. Like, why are we equating them if the question says the line does not meet? So listen to me carefully. You have to equate them first and then apply discriminant and then decide what are those values for which this line does not meet the curve. I hope you get the idea. If you haven't, listen to this carefully. Just rewind it a bit and just listen to it again, once again. Okay, so I equate them. Check this worked solutions. X squared minus 4x plus 7. Okay, so now this becomes x squared. Again, I'll do the same thing. I'll subtract 2x and a c on both sides. So this becomes a 0. X squared. This time the negative 4x and the negative 2x becomes a negative 6x plus a 7 minus c and equals to 0. Let's apply discriminant. B squared minus 4a and a c. And this time I'm going to put it less than 0. Reason, because I need those values of c, those range of values of c, obviously since it's an inequality where the line does not meet the parabola. So let's solve it. 36 minus 28 and plus a 4c. This is less than 0. It's just a linear inequality. So this will be plus 8 and less than 0. So 4c is less than negative 8 and c is less than minus 2. That's your answer for problem 2. So final problem, problem 3. Determine the range of values of a for which the line y equals to minus 3x plus a intersects the parabola y equals to x squared minus 2x plus 5 at 2 distinct points. Okay, so we equate them the same way we did earlier. X squared minus 2x plus 5. This will become x squared minus 2x plus 3x plus 5 minus a, put it equal to 0. X squared plus x and plus 5 minus a, and that is equal to 0. Now I apply the discriminant, b squared minus 4a and c.
and put it greater than 0. This time, this is again a linear inequality, minus 20 plus 4a and greater than 0. So 4a minus 19 greater than 0. A should be greater than 19 over 4. Okay, so that was it for this lesson. And if I summarize it, this lesson was a two-part series. The first was like the concept of discriminant, and then in later part, I told you how to solve the reverse cases where the nature of roots is given and you need to find some unknowns. And in the last part of the video, part two, the last part, I solved problems involving where you need to find the unknowns in those situations where a line is given and the nature is given like either the line intersects the curve at 2 points, is tangent to the curve, or does not meet the curve. Okay, so keep watching more videos for more useful lessons and resources that will be very beneficial for your exam preparations. And I'll be sharing more content on the discriminants and like the whole quadratics, the exam problems in my coming videos. Stay tuned. Over and out.